So we talked about waves, ripples in a pond, and we talked about waves, sound as a wave, and then another important wave I want to talk about is light. And actually, light is a wave, but light, visible light, is actually just one form or one cousin of a group of energies called electromagnetic radiation. So, welcome to the family of light energies or electromagnetic radiation energies. So I'd like you to be familiar with this. Here we have visible light, kind of smack dab, a little bit in the middle, and you might recognize some of these names. So notice that these are terms we've been talking about with regard to waves. We have frequency, or this is cycles per second here. So notice down here we have a low number of cycles. I know that seems high, 10 raised to the fourth. What's that? 10, or excuse me, okay, that's 10,000, okay? But over here, this is the number of cycles we have per second. And that's a lot, okay? That's a 1 with 20 zeros after it, okay? That's the number of cycles per second. So these are different cousins, that's their frequency. And down here, we have just visible light broken out. And we have the red color over here. That's actually the lowest frequency, and it's the longest wavelength. 700, N stands for nano, so 700 nanometers. And then over here we have blue light, and that has the highest frequency, the shortest wavelength. This is 400 nanometers. Okay, and that's actually kind of just expanded right here. So one of the things I kind of want you to be able to know is we have visible light getting longer wavelength, we have infrared, longer than that, we have microwaves, longer than that, we have radio waves. Shorter wavelength than visible light, we have ultraviolet, of course that's affectionately called UV, then we have X-rays, and we have gamma rays. So this is the short wavelength. This is the long wavelength. Okay. This is the high frequency, high F, and this is the low F. Okay. So, yeah, I think that is so cool. So one of the things they talk about in chapter 9 that I just want to mention is that as these various forms of electromagnetic radiation, just another wave propagating through space. Now, you might have heard me mention that these light energies, this family of energies called electromagnetic radiation, they don't need air to propagate through. These energies have both a wave aspect to them and a particular aspect to them that we call photons. I think that is so cool. And the photons behave, or they travel through space in creating a transverse wave. So one of the things that all of those photons, those energies, those waves, as they propagate through space, is they have to propagate, they have to go at a certain velocity that we've been talking about. So the velocity would be what? The speed of light, okay? And the speed of light, actually, just like the speed of sound is affected by temperature, the speed that light travels is affected relative to what medium it's passing through. So if it's passing through a vacuum, then the speed of light, and we say the speed of light, but it's the speed of all those forms of electromagnetic radiation. The speed of light is about 300 million meters per second. Okay? So if it's not through a vacuum, then light slows down. So And in order to gauge or to describe how much it slows down, we use something called the refractive index. And the refractive index basically is the speed of light divided by the speed of light in a vacuum divided by the speed that light goes in that medium. So for instance, here we have a diamond, okay, and here we have the speed of light. If I divide those two numbers, I get over here 2.42. So notice actually in terms of, these are arranged by slowing down. The increasing refractive indices, that means it is having more and more of an impact on light. And yeah, I guess that's all I want to say. Now, the fact that these different mediums can make light change speed actually has some great consequences in making some beautiful optical effects. All right. So, yep, the speed of light, and the variable for the speed of light is the variable c, the letter c, and that is approximately, if we go with just basically one significant figure, we can go with 3 times 10 to the, let's see, 6, yeah, 3 times 10 to the 9th meters per second.